Hello students, welcome to your pre-algebra review video. This is going to sort of go back over really briefly, just a 3,000 foot view of everything that we've done so far in pre-algebra, all the way back to the beginning. And then we will sort of take a quiz on some of the important fundamental concepts that we're going to need as we move into next year. So we begin with a discussion of operations with integers or operations with positive and negative numbers. Okay, so these types of problems are the types of things that you will be asked to do in the future related to this. It's just have a good understanding of what happens when we take a -3, for example, and let's see if we can get this to work here. We take a -3 and we add a -7, right? What do we get when we do a -3 plus a -7? A negative plus another negative makes it more negative, right? What happens if we take a positive and we minus a negative, or minus a positive that's bigger than that? So 4 take away 7, for example. In this case, we end up at -3 because we took away a bigger number. What happens if we take, let's say, -2 and we minus a -4? Minusing a negative is really like adding, right? -2 plus 4. Now we're at -2 and we're going up by 4, so we end up back above 0 as a positive, right? Because the positive is the bigger number. So we end up at 2. Okay, so adding and subtracting with negatives is important. It's also important to remember that when we do multiplying and dividing, a negative times another negative makes a positive, and also that a positive times a negative or a negative times a positive makes a negative, right? And all of these kinds of rules. Same is true for dividing, right? Times or divide by a negative, times or divide by a negative or by a positive. Okay, so remember those rules and how these operations, these basic operations, add, subtract, multiply, divide, work with positive and negative numbers as well. Okay, so that was mainly our first chapter, operations with negative numbers. Okay, we also looked at factors of numbers. So remember, factors are numbers that can multiply together to get a certain number. So for example, factors of 12, would be like 1 and 12, and we started making rainbows, right? 1 and 12, 2 and 6, 3 and 4. Right, we made these factor rainbows. Then we talked about things called greatest common factor and also least common multiple. Okay, so those were both in that same section, that same chapter about factors of numbers. So if you need to review either of those, go back and look at, that's chapter 4. Okay, chapter 4, factors of numbers. And you should be able to find that textbook on the Google Classroom. So yeah, factors of numbers that can multiply together to make whatever number you're given, right? Least common multiple is if we make lists of multiples for, let's say 2 and 5, it'd be 5, 10, 15, right? We made lists like this, and 2, 4, 6, 8, 10, and so on, and then we found the first common one in the 2 lists. That's least common multiple. Okay, so factors and multiples is what we dealt with in chapter 4. Then we dealt with fractions. Okay, we did a lot with fractions, starting with reducing fractions. Okay, reducing fractions from, let's say, 9/15, right? We reduce fractions by finding a common factor. So what are factors of 9 and factors of 15? Well, I can divide both by 3. Divide by 3, and I end up with 3/5. Okay, so we started with reducing fractions. We also then multiplied fractions, right? So we could multiply and divide fractions. 1/2 multiplied by 3/4. Remember, when we multiply, we just get to go straight across the top and bottom. We don't have to worry about common denominators when we multiply. That'd be 3/8. With dividing fractions, we flip the second one or find the reciprocal to turn it into a multiplication problem. So if we have 2/3 divided by 3/5, we would flip this one over and change it to 5 over 3 instead of 3 over 5. And then we change the divide sign to be multiplication. Right? And then we multiply straight across, tops and bottoms, don't need a common denominator. In this case, we end up with 10 over 9. Okay? So multiplying and dividing fractions we dealt with. We also dealt with adding and subtracting fractions. So remember, adding and subtracting fractions does require a common denominator, and then we simply add or subtract the numerators. For example, if you have 5/6 minus 1/5. Okay, 5/6 minus 1/5, we need a common denominator first before we can do any subtracting. This is where least common multiple came into the picture. We need the least common multiple of 6 and 5, which ends up being 30. So we do 6 times 5 to make 30, and we do 5 times 6. Then we do the same thing on the tops that we did on the bottoms, and we end up with 5 times 5 is 25, minus 1 times 6 is 6, right? And so now we have a common denominator, so I know that's going to stay the same. And now because I have a common denominator, I can add or subtract. In this case, subtract my numerators. 25 minus 6 is 19, so I end up with 19 over 30, okay? So add, subtract, multiply, divide fractions. Brush up on that if you need to, and then, of course, always be able to reduce them. Then we expanded fractions to looking at ratios. We looked at ratios, and more specifically, we looked at proportions. Okay, proportions is a really, really important skill for us to have. So that's where we have an unknown value in a fraction, but we know it's equal to some other fraction. So, you know, for example, we have 7 over 10 is equal to x over 4. Right? 7 over 10 is equal to x over 4. We're trying to find this unknown value. So we did a couple different methods. We call them potentially the fish method or cross multiplication. Essentially, we multiply the top of this one and the bottom of this one. We multiply the bottom of that one and the top of that one. Set those equal to each other and then divide away this number. Okay, so we get 28 divided by 10, which is 2.8. Fish method just says we can start on the side with the x, start at the number, multiply up, and then divide, and that'll give you x. Set 4 times 7 divided by 10 will give you x. 4 times 7 divided by 10. That's the fish method. Okay? And we get 2.8. So we did some other things with ratios, reducing ratios, just like fractions and so on. But the thing I want you to focus on, and it's really important to remember as we move on to Algebra 1 and also geometry, is this idea of proportions. Okay, so solving proportions like this. Then we did percentages. Percentages was also a big application of proportions. We spent a lot of time on percentages, you know, specifically trying to answer word problems, right? We talked about fraction versions or decimal versions or percentages. We talked about, you know, x over 100 is equal to, you know, some quarterback completed 12 out of his 15 passes. What percent is that? We set up this fraction, or this proportion, I should say, 12 out of 15 is equal to x over 100. We did the fish method, and we got, you know, x is equal to whatever x is equal to. 80, I think. Could be wrong. 12 over 15 would be 4/5, right? 4/5 is 80%, yeah. Right, so x is 80, in this case, 80%. So percentages, we did a lot more with proportions. We did a lot of word problems. If you need help with any of that or are unsure about how to deal with percentages, let me know. Or if you're not confident in your ability to deal with percentages, let me know, and I will be happy to help you or send you some extra practice on that. After that, we talked about solving equations, starting with pretty basic equations and eventually ending up with two-step equations. So we solved equations, you know, like x plus 5 is equal to -2, right, where we minus 5 on both sides to get rid of that plus 5, and -2 minus 5 more is -7. So remember, when we're solving equations, we're doing the opposite of whatever we see happening to the variable, and we do it in the opposite order, okay? So in this case, because we saw our x being plussed by 5, we minus 5 on both sides of the equal sign, and we arrive at our solution. We also did some maybe like this. That's supposed to be a minus sign. Whoops. That's a minus sign. Minus 2 is equal to 4. Okay. So here's a two-step equation where there's actually two things happening to the x. One of them is it's being multiplied by 3, and the other is it's being minused by 2. Remember that when we solve equations, we deal with the order of operations backwards, which means we're always starting by looking for subtraction or addition, and we undo those first. So I undo the subtraction with addition by adding 2 on both sides. 3 times x then is equal to 6. Then I undo the multiply by dividing, right? Because that's the opposite of multiply. Divide by 3, and I get x is equal to 2. Okay, so we solved one and two-step equations, and then we also looked briefly at inequalities. Okay, inequalities were, we have like x plus 2 is greater than 4, and we can solve that and get, x all by itself. In this case as well, we just have a greater than symbol instead of an equal to symbol. And then we talked about graphing these on a number line, right? Where we made a number line and, we counted up in the negative, counting closer to 0. So like -2, -1, 0, 1, 2, 3, etc. We found the boundary point. We either put an open circle if it was not equal to, or a closed circle if it was. And then recognize that, okay, x being bigger than 2, 3 is bigger than 2, so I want to include 3, so I'm going to put my arrow this way, okay? So that's what we did with inequalities. We solved them, we put them on a graph, on a number line, so we could see all of the infinite solutions, all the numbers represented that are bigger than, in this case, 2, okay? And then we've also dealt with linear equations more recently. And then the only other thing we've dealt with since we've been in our distance learning setting is things, square roots. So linear equations, the key here, the most important thing here, you guys, is slope, okay? If we have an understanding of slope, then we are well prepared for Algebra 1. The rest of chapter, 8 that we've been looking at, chapter 8, is good stuff. In terms of finding intercepts, that's an Algebra 1 concept. Or, determining if something is or is not a solution to a linear equation in those two variables, y and x. Functions and mapping diagrams and all that stuff is going to come back in Algebra 1. Slope is something that is going to continue on for the rest of your life. So if you have an understanding of the slope formula, y2 minus y1 over x2 minus x1 as a fraction, you are, as I said, well prepared. Okay, so the key is being able to take two coordinate points, 2, -3, 7, 4, and can you find me the slope? If you can do that, then I'm satisfied. And then, like I said, the last thing that we did, some chapter 9 stuff, was about square roots. Okay, we talked about square roots of perfect square numbers, right? So perfect square numbers would be like 1, 4, 9, 16, 25, 36, 49, 64, etc., right? These are the perfect square numbers, so we can square root all of those, right? We talked about the Pythagorean theorem in this chapter. Not a right triangle where we're trying to find a missing side. So in this case, missing hypotenuse length. A squared plus b squared equals c squared was in this chapter. And then, yeah, as I mentioned, just square roots. We also talked about rational and irrational numbers, I believe, dealing with square roots. Remember that if we have the square root of, let's say, 12, that's not a number from our list. And so this number would be an infinitely long decimal that's never going to stop and never going to repeat. We call that an irrational number. Okay, so we talked about different types of numbers, right? Integers, rational numbers, irrational numbers, whole numbers, natural numbers, and all that fun stuff. You can review all that stuff. Material is still on Google Classroom under Chapter 9. So if you have questions about any of this stuff, square roots or different types of numbers or the Pythagorean theorem, look there. Like I said, if any of this stuff jumps out to you and you think, I have no idea how to do any of that, Mr. Freitag, I've never seen that before in my entire life, please let me know. I will remind you of when you did see it before in your entire life and try to send you a little bit of extra practice so that you can brush up on that before we leave for the summer. So like I said, if you have questions, let me know. I'm around. I'm happy to help. Otherwise, that's all I have for you right now, and we'll talk to you soon.